ordinary aircraft must have forward speed to fly. The reason speed is necessary lies in the shape of the airplane's wing. Examination will show that the wing has been designed so that its upper surface is more curved than its lower surface. When the airplane is in motion, air rushes past the wing. The air passing the upper surface moves a longer distance in the same time as the air passing the lower surface, and therefore moves past the upper surface faster. This difference in air speed increases as the airplane itself moves faster and creates a partial vacuum along the upper wing surface. The normal air pressure under the wing lifts it into this partial vacuum, which enables the airplane to fly.
Gravity's our friend and our foe.
Planes fly because the propellers push the plane forwards, pushing air over the wings. The wings then convert this airflow into vertical lift. Every pilot is taught that planes fly because of the curvature on the top side of the wing produces low air pressure, which then generates vertical lift. This low air pressure is a result of rapid airflow and relies on something called Bernoulli's principle. We call this the conventional theory. For now, let's just focus on one of these many problems. This conventional theory cannot explain how planes can fly inverted. When the plane is inverted, the curvature of the wing is now facing downwards, not up. So the wing should pull the plane towards the ground, according to this theory. Obviously, this doesn't happen, as planes can fly inverted in the real world. So the conventional theory fails. It's generally agreed that planes' wings displace some air downwards that helps them stay airborne. The debate here is on how much lift is generated by mass displacement. My mass displacement theory is based on the same principles that explain why hot air balloons and boats float. Namely, that they displace a mass of air or water that is equal to their own mass. If they don't, then they sink. In normal flight, the wings function to generate lift in two ways. Firstly, the underside of the wing pushes air down, as reflected by the high air pressure under the wings. And secondly, the curved upper side of the wing also pulls air downwards, as reflected by the low air pressure on the top of the wings. So the low air pressure on the top side of the wings helps to generate lift, but just not in the way that conventional theory says. The essential thing needed for a plane to fly is a positive angle of attack on the wing to displace air downwards and keep the plane afloat. Wing curvature is not essential. Simple. In inverted flight, the wings still function in a similar way to normal flight. The wings maintain a positive angle of attack and displace air downwards. Only, the wings are less efficient as the wing curvature is also inverted. This is compensated for by raising the nose of the plane so that the propellers also generate lift by pushing more air downwards. Boats can rise out of the water and float on the air for the same reasons that planes fly. As the boat goes faster, it displaces a greater mass of water and air, pushing the boat upwards. Physical evidence for mass displacement is the backwash behind the plane. This is similar to the wake that a boat leaves in the water behind it. Mass displacement as the cause of vertical lift is consistent with what we see elsewhere. Not just boats, but hot air balloons, gliders, parachutes and paraponts. Even birds fly by pushing air downwards or using rising air currents to push them up. Planes are no different. It's all mass displacement. It's total bollocks.
Nothing escapes its pull.
It's total bollocks.